Section 7.2, Calculus of Parametric Curves. Now, mostly what we're going to be talking about are the derivatives of parametric equations. It says, consider the plane curve defined by the parametric equation x equals xt and y equals yt. And it says, suppose that x prime of t and y prime of t exist. So we have to have those derivatives to exist in order to talk about the derivative. So now what's nice about this, and assume that x prime of t is not 0. Now that's necessary because when we look at the bottom of this equation down here, we see that the x prime of t can't be 0 because we can't divide by 0. So anyways, so now taking a look at this, it's saying, hey, that dy dx, that means the change in y over the change in x, which means the derivative of y with respect to x. So in essence, what we can say is dy dt over dx dt. And that's what y prime t over x prime t means. So what we're going to do is we're just going to jump to some problems right away. This is very straightforward as far as the notation is concerned. Now again, the idea of using them in this way might be new to us, but derivatives definitely are not. So let's talk about some general directions of what would use the idea of this derivative. So take a look at directions for this problem. So this says determine the slope of the tangent line, then find the equation of the tangent line at the given value of the parameter. So the idea of slope here that we see means derivative. If we think about the idea of slope of a line, we can find slope at a point by using this idea of derivative. So that's essentially what we're going to do here. So now they gave us a parameter for our t, which is pi fourths. So that tells us we have to find our point first, right? If we're going to find the slope, we need to find our point as well. But before we do, all we're going to do is use our handy dandy formula, and then we'll do the point. So anyways, it says that my dy dx is going to equal y prime t over x prime t. And we're assuming that x prime t can't be 0, and it's not here, so that's fine. So the derivative of y here is going to be negative 3 sine t. Because keep in mind here, the derivative of cosine of t is negative sine of t. And then now we're going to go with the other one here, and that's the x, because the x prime t is on the bottom. So the derivative of x with respect to t is going to be 3 cosine t. Okay, so there we go. And now we actually have this pi fourths now to get the specific derivative at that value, which means that's going to be the slope of that point at that value. Slope of the point. Yeah, at that value t, yes. Okay, so anyways, so now what we're going to do is I can call this negative tangent t, right? Because, oops, I forgot something. I forgot my 3 tangent t. Okay, so now I can just plug in that pi fourths there. And I know the tangent of pi fourths is 1, and then times negative 3. Okay, so when I go negative 3 tan pi fourths, I know that that's going to be negative 3 times 1, which equals negative 3. So actually the derivative at t equaling pi fourths is negative 3. So now we have the slope that we need at that given point. So we should label the point as well. So then my x value is going to equal 3, and the sine of pi fourths is root 2 over 2. So I'm just going to write it in there. If you're not familiar with those, get more familiar with those guys. So 3 square root of 2 over 2 is going to be my x. And my y is going to equal 3, and cosine of pi fourths is also root 2 over 2. So this is also going to be 3 square root of 2 over 2. So my x and my y are the same values. They're both 3 square root of 2 over 2 for my x and my y. So there's my point now. So now we have the point, we have the slope. So now we can actually find the equation of a line. Now recall, the equation of any line, or I should say most lines, is y equals mx plus b. Now we have the slope. Okay, the slope is -3. So I really have y equals -3x plus b. And I also have an x and a y I can plug in here. And those are those values I found here. There's my y, there's my x. And I can actually just plug those in now and find b. So I will say that my y is 3 square root of 2 over 2 equals -3, and my x, there's another x there. So that's my, not another x, I'm sorry, that's my x. The other one was my y. 3 square root of 2 over 2, comma, plus b. So now all I have to do here is simplify and solve for b, and then I'll have my equation of my line, my tangent line to be specific. Okay, so this is 3 square root of 2 over 2 equals -9 square root of 2 over 2 plus b. So that means I'm going to have to add 9 square root of 2 over 2. So that's going to give me 12 square root of 2 over 2, because I can add those together because they're the same irrational number. Okay, and then when I'm going to add the 9 and the 3 together, and that's going to give me the 12 because I'm going to be adding 9, blah, blah, blah. That's the idea. So anyways, so I get this equals b. So now I have the equation of a line because I have the b and I have the m. And that's really all I need here. I had one specific point, and that was only to help me find b here. So anyways, so now my equation is y equals, and I have my slope, -3x, and then my b then is going to be plus 12. And I'm going to simplify that. I don't want to write 12 square root of 2 over 2. I can simplify this and call that 1 and 6. So I can say 6 root 2. So there's my tangent line. And that's the second part of this. So my first part I needed to do here is I needed to find my slope, which was here. Or my slope at the given point. And here is what I was trying to find, because it told me to find the tangent line for the second part at the given value of the parameter. And that's what I found here for t equals pi-4. So there's our answer using calculus of parametric curves.